In the last video, we went over finding the inverse of f of x equals 2 to the x power, both by the graph and algebraically. And what we found was that y equals 2 to the x, its inverse was y equals log base 2 of x. We found that the domain was the same as the range of the inverse and that the range was the same as the domain of the inverse. And we found that both of these graphs were increasing. Let's do the exact same process on finding the inverse of x, or 2 to the negative x power. So I can rewrite this as f of x equals 1/2 to the positive x power. So we'll kind of keep that in mind. And so first by the graph, let's get some ordered pairs of my function. So I will use my calculator again. And I'm just going to do 2 to the negative x power, but you can put that in as 1/2, but you do have to put parentheses to the x power. So I will graph that, and here is my graph. I'm going to go second table to get some values. So I'm actually going to start at -3 and go to 2. So -3, -2, -1, 0, 1, 2. And that is 8, 4, 2, 1. That's a half and a fourth. What should make sense because my base is 1/2. You're cutting everything in half. So divide by 2, 4, divide by 2, divide by 2, divide by 2, and divide by 2. So let's plot those points. Okay, and so then this does now look like my graph. And let's remember, before we connect these lines, that I have a horizontal asymptote at y equals 0. So when I connect my dots, I'm not going to go over that x-axis. I will stay above it. Now, of course, I am human. So it looks like my graph right here is bouncing off that x-axis and coming up. That's a bad graph on my part. It does not need to touch it. And technically it's getting closer and closer and closer. It's not going to go up like this. Okay, but that's a human graph for you. And then if we talk about my same domain range, when I go left to right, that's -infinity to infinity. My range, when I go from bottom to top, starts at that horizontal asymptote of 0 to infinity. And then last thing we're going to note is what's already on that graph, that we have a horizontal asymptote at y equals 0. So again, we went more in depth about how to graph this in lesson 3. So if you need to go back to lesson 3, go back to lesson 3. All right. So now to do the inverse of my function, I'm just going to take my x and y coordinates and switch them. So my y coordinates now become my x. And my x coordinates become my y. So now I'm going to plot these points. Okay, and before I connect these, you can see here that this is going to keep going 1/8, 1/16, 132, 164. It's going to keep getting closer and closer to 0, but it will never actually get to 0 because we have a vertical asymptote at x equals 0. So when I connect my points, I will not cross that axis. And again, it looks like it's kind of bouncing and going further away, but we know that's getting closer and closer and closer. And so if we remember again that my inverses mean that it reflects across the line y equals x, and you can see that it is a mirror image of each other. I am going to label this one. This was y equals, I'm gonna go ahead and just do 0.5 to the x power. And so here, I don't know what to name my red line, my inverse, right? So that's when we jump down here to algebraically. So my function was, I'm going to go 1/2 to the x power. So I'm going to go 0.5 to the x. So the first thing I need to do is change my function notation. We'll go y equals. Once I change my function, my f of x to y, now I need to switch my x and y. So I have x equals 0.5 to the y power. And now we solve for y. Well, I don't have a way, algebraically, I guess, to solve for an exponent or to solve for a variable when it is in the exponent position. So I can call this graph x equals 0.5 to the y power, or if I rewrite this using my log definition that's on that first page here, this is base 2 equals, so log base 0.5 of x, and that equals my exponent of y. So my last step would be changing this to function notation, and this is log base 0.5 of x. So this is the same as y equals log base 0.5 of x. Let me make that 0.5 a little bit smaller because that should be down there. Okay. So let's talk again about the same domain and range of my log. The domain, when I go from left to right, the first thing I go to is that vertical asymptote at 0. And then it's going to keep going forever to positive infinity. And then my range goes from the bottom to the top. So we go arrow to arrow. So that's negative infinity to infinity. And then the last thing we're going to talk about is that it has a vertical asymptote at x equals 0. And so this talks exactly about what we just went over. Notice the domain of my exponential is the same as my range of my log, while the domain of my log is the same as my range of my exponential. And so that's what it's saying right here. The domain of a log, equals the range of an exponential, which is 0 to infinity. The range of a log is the same as the domain of an exponential, which is all real numbers. And then the last thing we're going to talk about again is that both of these, the exponential and the log, both of these graphs are decreasing. You can look from the graph, or you can see as your x's are getting bigger, your y's are getting smaller. As your x's are getting smaller, so are your y's.